Hey guys, so today we're going to talk a little bit about propellers. It seems to come up on forums a lot, what to run, what does what. So I'm going to give like a little bit basic talk about what some of them do and the shape, design. So it can help you pick a little bit better on the propeller choice, because there's no math when it comes to picking these for what you have for your batteries, for your speed control, your motor. It is a general guessing game and playing with different profiles of propellers and sizes and pitches to find that perfect combination. So, what I have here, here's one right here. I have a few different styles. Here's one right here. Another style. So each one does their own thing, and for individual different boats. So one boat may like one style of propeller, another boat may like another style of propeller, and so forth. It just depends on the batteries, the motor, everything that is being ran in the boat, and how the boat is set up. A lot of people understand, let's take, a propeller, let's go with the biggest one we have. So here, this one's about a 48 millimeter propeller. So if I slap this one on one of my smaller boats, would say, one of them I have on my shelf. Anyway, so this will definitely easily overheat one of my boats because it's just too big. It's a very heavy propeller and the motor just does not have enough torque for it. So a lot of times the easiest way to do it is you factor what the stock propeller in the boat came with, and then do your playing around. Start with your pitch first and slowly work up from your pitch. For example, let's take this 442 propeller I have right here. So it is a 42 millimeter by 1.4. What I usually do when I'm testing a propeller is I'll start with the pitch first. So this would be like a 42-14. Then I will work up. I had a 42-16, and then here is a 42-19. I'll start working with the pitches first. See how it kind of works out from there, and then I'll start scaling up and going on the size. I have another propeller that's on another boat right now, which is a 43-14. And so, I'll slowly start working on the pitch from there and going up a little bit until I can find a perfect match. And that perfect match is in between speed, runtime, and temperatures. Temperatures is your biggest tuning aid. The people that will lick their finger, touch the motor is not the best way of doing it. Spend the extra couple dollars, get yourself one of these. This is the best tool you can use. When you're running these boats, it can give you an accurate temperature reading to stay within a certain degree to find that setup on yours. Because one propeller can run really good, let's say for example at 100 degrees, and another one that is very similar but a little bit bigger, or how it's designed or made or cut and balanced, can run another 20-30 degrees higher. It doesn't take much with a propeller. The easiest way to understand it is, thinking about like if you're going uphill in a car, 4-cylinder car, it's a manual, you're going up this hill and you're thinking, oh, we'll just put it into 4th gear, it's going to be fast. What happens, the motor starts lugging down, it just does not have that power, the temperature is starting to come up, you're starting to issues. So, common sense, you would shift down, put it in lower gear. So boats, we don't have a gearbox to work with. All you have is a motor, you got your input voltage, and what your amps of your speed control can handle. So those are your variables from there. You do have the hull type. Each hull is a little bit different on how they run, but there's some common variables to a point. But with your boat, you can easily kind of start figuring those variables out by playing around and doing a little bit of learning. There's a lot of information out on the web. So I'll usually start kind of backtracking. I'll usually start with pitch first, work my way up from there, and then start working on diameter and start going up there. Each propeller design, as you can see, is you have one design right here, you have another design here, another design here, As you can see in here, this one has more what's known as, a tongue here, versus this one is less. Each one of those have a purpose. Hold on, I'm grabbing another one. So here's another propeller. You can see the shape of it, you see the blades. Alright, so each one has a different job to do, as I call it. So starting off with, basic design for understanding is, these propellers have what's known as a tongue right here. This tongue right here helps you dig into that water and get up on plane. It helps with a lot of acceleration. So the more tongue you have, the better it's going to be out of acceleration and coming out of the hole and getting on plane. Now it does, cause it, can be problematic for going really fast, because this tongue is, if you imagine this blade is rotating and turning, so the tongue is your lowest point of your pitch, and then your pitch gets bigger and bigger all the way until your final pitch of whatever the pitch of the blade is. So every time the propeller turns, that low pitch goes in the water first, then the pitch increases, pushing the boat farther, pushing the boat forward ahead. So sometimes having a tongue can be good, sometimes it can be bad if you're trying to chase down speed. So when you're doing a lot of speed, a lot of people will go to like a D-tongue, which, out of the hole, acceleration is going to hurt until you get to the top end, and this is where it's going to really do really well. So sometimes, so also going in between to where, like, for here, this propeller, as you can see, it's got a little bit of tongue. It's not a lot there, but to me, they kind of work as like a medium between, my driving style. Also, some other differences with propellers is, when talking about diameter is from tip to tip. The pitch is, how much the blade is curved backwards to grab the water and push it forward. If you can imagine a screw, like any type of wood screw. See if I have one around here. So here's like a wood screw right here. If you imagine a wood screw, so the screw portion here is considered what's known as pitch to a propeller. So every time the propeller turns, it's like a screw and screwing into the water. So, let's take, a screw, a low pitch is going to be very similar to, a fine threaded screw, as the easiest way to describe it. So the finer the threads, that means more turns it's going to take, to complete, and that to screw all the way in. So as a propeller, the lower the pitch, it's going to take more turns per revolution to equal out the same revolution as a higher pitch one, as like this screw. So, depending on your motor and your torque available and your RPMs would depend on if you want more pitch or less pitch, and it just depends on if that motor can support it or not. Usually with higher RPM motors, there's a lot of differences and variables to play with, so it's like not one setup is always correct. Now, I have another propeller here. As you can see, the blades come out here. This is known as rake. The rakes with propellers, they vary in sizes, how much they're forward or backwards. What rake really does and helps and achieves is how that thrust of that water is pushing the boat and pull trail and pushed away. So let's take this high rake, this prop right here. So as the water comes through, it hits the blades and the blade is turning, and then the water is being forced back. Well, with the rake of the propeller, think of it as a cone. So when the water's coming off, it's coning off and fanning off. So the rake narrows down that cone, so it's a more narrower flow of water coming out of the back of the boat, which can equal in a few different senses as being a little bit quicker. Also, bring an example is it will create less, bow lift as it's called, and and push the bow down into the water. So sometimes if you got a high raising bow, actually I'm sorry, I'm backwards. A higher rake prop will give less transom lift and push the bow up out into the air a little bit more. So with those. So when you also hear low lifting props, which would be also a low rake prop, similar to this one right here. So same theory again, and same understanding is it's like a cone that comes off. So the less of the rake, the higher the cone pattern is, and a lot of it comes out, out of the surface of the water, because a lot of these are surface running props. It comes out of the water, and then so in turn it takes the back of the boat, pushes it up out of the water, pushing the bow down into the water. Now, depending on those type of props, some boats prefer one or the other. It seems like, to me, and a lot of forums I've read and stuff like that, is the higher rake propellers do better with like the mono boats like this, because it helps get more of the hull out of the water, is what you kind of want. Because the more it's in the water, the more wetter it is, and potentially a little bit slower, things start heating up a little bit more, and so that way it can ride a little bit better. But again, there's so many different variables. Each setup is not consistent from one to the other. You can have one setup that's running good, the other one's just a little bit off. Each boat I consider has a personality of their own, and you would have to play around with different ones. I've been experimenting, trying different ones, recording speeds, my temperatures, how the boat runs, and trying to figure out which one likes and what doesn't like. So I created a little bit of stockpile and slowly kind of build them up, fit them out a little bit, and try different ones. It's not a direct, it's not a full silence on doing it, just a little bit of a guessing game. But usually you take the numbers from the stock propeller and you will kind of go up a little bit, go down a little bit, and play with it, and just using your measurements, using your temp as your readings, and have fun with that. And sometimes it could be very rewarding, successful. Sometimes it's going to come with headaches, trying to get it figured out. That's kind of one thing about owning an RC boat, and it's a hobby. It's meant to have fun, learn. There's a lot of information out there. A lot of people know exactly what they're kind of talking about, and you can pick up a lot of information from many different people. So hopefully this kind of helps a little bit with kind of topics of propellers. A lot of it is a big learning game, learning challenge also, and they go really in depth, far past what I'm still currently know, which I will still say I'm still kind of learning on some of them, but still having a good basic the understanding of propellers and how some of them work will really help you out on finding a better setup and having your boat run cooler, faster, and more to your liking. So, well, anyways, thanks for watching.